Imagine an extremely hot chocolate cake coming out of the oven. When it's first taken out, the temperature is 350 degrees Fahrenheit. But over time, the temperature will decrease considerably, gradually approaching room temperature. In fact, according to Newton's law of cooling, an object's temperature modeled over time as it cools can be represented by exponential decay. And this is just one of the many instances in statistics where we can take real-life situations and use certain recognizable patterns to model them. One model used in particular throughout the fields of math and science to model data is a logistic curve. A logistic curve is an S-shaped data model that closely resembles exponential growth but levels off at a certain y value. It is most often used to model categorical data. For example, we could use a logistic curve model to predict the probability of a student being offered a place on a postgraduate course based on their entrance exam score. The original data points which we used to create our model represent either yes or no, meaning they are binary values. But what about situations where the dependent variable is not binary? Can we still use logistic curves then? The answer is yes. And to demonstrate, let's conduct a little experiment involving the spreading of a rumor in a class of 31. On the first day, only one student knows the rumor. We can select an integer from 1 to 31 at random to decide who this is, and it turns out to be student 27. Now on day 2, student 27 tells one other person, which happens to be student 28. On day 3, we have to choose 2 more students to tell the rumor, so now 4 people know. Then 8, then 12, and then 19, and so on until all the students in the class know the rumor. We can now take our data and graph it, and as can be seen, the shape is indeed a logistic curve. We can now utilize a special equation known as the sigmoid function to model this. Inputting our data into a calculator gives us the following equation and curve. Although the dependent variable in this case was not binary, we were still able to generate a logistic curve. Logistic curves also have an astounding number of real-world applications. Maximum likelihood is a process that involves creating numerous curves through data points and calculating the product of the y values for each curve, then choosing the curve with the highest such product. This, like linear regression, is a classification algorithm and is used very often in the creation of neural networks and in machine learning. Logistic curves are also a great way to model populations of species over time. Bacteria growth, populations of cities, and even cases of COVID-19 are just a few examples of what logistic curves can model. Not many people know about logistic curves, but their capabilities are endless, and we can represent so many real-life situations with their help.